So hey guys, thank you for coming. I hope you enjoyed the talks and the coffee, and the sandwiches. I definitely did. Thank you for the host for this great dinner and the coffee especially. I'm Attila Bujaki. I'm going to give a talk about cloud native event streaming written entirely in Rust. So it's pretty much a Rust native solution. And I really wanted to introduce my first a tiny bit. I'm working at a small fintech startup, Genius Yield. We are working on a suite of different decentralized finance protocols, mostly building on the Cardano blockchain. It's also a smart contract platform. It's more like a new area, a pretty new domain. We don't have like decades of old code base, so we have more like the greenfield kind of environment. And we also do have some stuff in Rust. I just wanted to mention that we are working on different products. On one hand, we are building a decentralized exchange with AI capabilities. We are building a business accelerator, Genius X, and we also provide an academy with online courses and teaching materials. The whole smart contract platform, Cardano, is built by IOG, and most of it is open source. So you can see the code and you can get a lot of data out of it. So that's why I had a closer look what it looks like. There are quite a few different code repositories written in different programming languages. And after looking at the data, I could see, wow, Rust is actually the second most commonly used programming language in this domain. There's also some data from the whole GitHub. 1.5% of all GitHub projects is already written in Rust. But you can see in this domain, it's more than 10%. So Rust is definitely something very common. And this is actually also pretty much what is the trend like. Like also the meetup is growing. Rust is used more and more often. And of course, in such a new domain like decentralized finance, there are new software projects, and it's often chosen to be written in Rust, mostly the backend things, of course. And the tool that I would like to present to you is TextPipe Oura, which is part of a Toolbox, the TextPipe Toolbox, which is a suite of different tools to interact with the Cardano blockchain, process events, write back things, and so on. And as I said, this is like a suite of tools, a toolbox with a lot of different tools. And most of the things that's already ready to be used is actually written in Rust, including Oura, which is a tool that can pretty much turn the static blockchain into an event stream that you can then consume. But before we dive into the details of this tool, just wanted to talk a tiny bit about blockchain technology, pretty much like a blockchain 101. So we have a basic understanding of this domain. So it's a distributed system. It's pretty much like a distributed database. You have different nodes, and each of these nodes is storing a copy of the blockchain. And these blocks are linked together, secured in a cryptographically secure manner. Usually there are different hashes used for this and different other mechanisms. The main thing is that the blockchain itself is an immutable ledger that's distributed and trusted by the participants of the network. What is very special about the Cardano smart contract platform that it has smart contract capabilities, which means that you can actually write program code into the blockchain, which can be then executed by the participants of the blockchain. So you can pretty much invoke functions that are written into the blockchain and use these as like agreement contracts. That's why it's called smart contract. And of course, there are a lot of interesting questions around this whole topic. What kind of consensus mechanisms you're going to be using? Who is going to be adding the next block to the blockchain? What's going to be the rules of this? if there are several different versions of the blockchain, this is going to be the valid one, and so on. And of course, as generally, building a distributed system is still hard. It's a complicated, hard problem, and that's why we need good tools that we can use to interact with them and use them. Here are these tools like TextPipe Oura that are very useful in this space. And as I said, Oura is a Rust native pipeline that's creating a near real-time event stream out of the blockchain. So what we're going to see is that we have the blockchain consisting of different blocks. And Oura converts this into a stream of events. So every time there is an event, like there is a new block in the blockchain, Oura emits a new event. Of course, the blocks are consisting of different things like transactions, and then a new block is added, then a new event is omitted by Oura, and so on. This is how you can consume the blockchain as it is growing, as new data is added to it, and this is a very cool approach, because this is turning the decentralized, distributed data structure of the blockchain into something that you can easily integrate into your own system, your enterprise environment. Because this kind of approach, like having an event stream, like a Kafka stream, is pretty much common nowadays. And this way, it's very easy to also integrate such data structures. I really wanted to show you how this tool is built up, because there are some very cool architectural styles, design patterns in this design, and I think it's very interesting. It actually makes sense that it is using the pipes and filters architectural style. So you're going to have like sources where the events originate from, and you can define different filters or enrich these events. And of course, in the end, you want to send these somewhere. And all of this is part of the tool, so you don't really have to do much about this. You just configure this whole pipeline. And what is an interesting design approach is that it's using active objects. So all of these components, like the sinks, filters, sources, they are not going to be just like static code, but each of them are going to be running their own threads, producing and consuming events. So this is pretty much what the active object design pattern is about. And what is really important in the cloud native space, where you cannot really rely on pretty much anything, because things just go down, things are not available, that resiliency is built into the system. Each of these components are built in a way that it is having such things like retries, timeouts, and so on. So all the things, sources, everything is going to retry everything if it's like failing the first time, and so on. So it's pretty much built for the cloud native space. I also wanted to show you a tiny bit of Rust code. We are at the Rust meetup, so let's start with some of the sources that we can use. Of course, these sources are going to be reading from the Cardano blockchain. We need some way to access the blockchain. We can run our own Cardano node, which is going to be really connecting to the other nodes and get the data from there and synchronize it. This can be done using a Unix socket, so Oura is going to be using a Unix socket to connect to the Cardano node, and the rest is handled by the Cardano node itself. Or we can just use a TCP connection to another existing relay of the network and get the data from there. And the cool thing is that these sources are already implemented by Oura. So it's going to be in the sources directory of the Oura tool, which is an open source tool hosted on GitHub, as you can see. And yeah, let's see, for example, this one here. You can see if we go to the setup RS, which is usually the file that's bootstrapping the component, we can see what I was pretty much talking about earlier, that it's spawning a thread, and it's going to be running its own event handler thread, reading from the source and then pushing it to the downstream components of the pipeline. And of course, we also have different filters So we can filter the events coming from the blockchain. As I said, we have the blocks in the blockchains, transactions. These transactions are usually sending something somewhere. It could be the native cryptocurrency of the blockchain, some tokenized assets, like different companies do already have like tokenized shares. They put their shares on the blockchain, and this can be traded freely. And these can be also all filtered. So like you can set up a filter. Okay, I'm interested only in the transactions related to the tokens of Genius Yield on the Cardano blockchain. And that's how you can set up the filters. All of this can be easily configured using a TOML file. And this is all visible in the selection Rust file. You can of course see different functions implementing these different filters, like looking for a different specific address. For example, I have an address on the Cardano blockchain. Maybe I want to see only the transactions that are related to me, to my address. Then I can filter for those and do something with these events and so on. And as I said here as well, it's spawning a thread. It's going to be actively running and processing the events. This also can be combined with any of or all of. So it's like an and or condition can be constructed out of these different filters. And the really cool thing that comes with Oura that I really like, that they have a lot of different filters. So these events that are coming out of the pipeline, you can send it like pretty much anywhere, to Kafka Stream, AWS SimpleQ service, write it to a log file, a Redis cluster, RabbitMQ, whatever you want. It's all coming out of the box. You don't really need to write code. You can just like configure this in a few lines of TOML file, and then it's ready to go. And that is where the power comes. Like you just spin up such a Oura instance, and you can just connect it to your own Kafka cluster. You already have it in your enterprise, and that's it. You've already integrated the Cardano blockchain to your enterprise landscape. And I also prepared a tiny demo just to show you how simple it is to get started with Oura. I was already talking about the TOML configuration file. That is what you can see up there. You just have to define a source to tell Oura where it should be reading the events from. The easiest way to get started for development is just to use a relay hosted by somebody else. Of course, you could be also spinning up your own Cardano node and having your own node of the network, but that's quite much work. You can just connect to an existing relay and read the data from there using a TCP connection. And just for the example, I defined the terminal sync. So if we're going to see the events just simply written into the terminal in a human readable format. And in order to make this all really runnable, I also wrote a tiny Docker file, which is like really not doing much. Just taking the official Oura release, copying the configuration file from above to the Docker image, and then just starting Oura with the configuration file. And that's it. And yeah, let's see how this works. The thing is that when you start this, it's going to start reading the different events from the blockchain, the different data elements. Of course, the blockchain itself is built up from blocks. And the blocks do consist of transactions. In these transactions, you can see different things, like assets being transferred, UTXOs, which is like also kind of like transfers. You can see that they are also defining these collaterals up there. That means that they are actually using some kind of smart contract functionality. So you can see that there is quite much going on the Cardano mainnet blockchain, and it is actively being used. If you are curious, this block that was printed to the terminal here by Oura, you can look it up also in a blockchain explorer. If you go to this address, then you are going to see the very same block in a web interface. So you can pretty much look it up what all of this means, like what is this milk, like what else there are at that address, and so on. So it's pretty cool. My experience up until now with Oura is pretty good. Like, it was super easy to get started with, and this is what I meant, that with Rust, even if you are actually a beginner, of course you're going to get a lot of error messages, but you kind of have the feeling the compiler is your friend. It's really trying to tell you, this is the error and this is here. It's even printing a tiny little caret to show, okay, this is the character where you made a mistake. Because with some programming languages, they make so cryptic error messages, it's crazy hard to find out what the problem is. With Rust, you kind of have the feeling that it's trying to help. But back to Oura, the local setup was super easy, like you saw. Just a few lines of code and you can get started. And that's really fun, because you can start building, and that's what we like to do, build stuff, right? And as I said, you don't need to run your own infrastructure, your own node, your Cardano node, but you can just connect to a relay and get started. And that's actually the cool experience. You need like 2-3 minutes and you're up and running. And the community is really great. Like online, you can see so many toxic communities, but here you can actually get help. People are happy that you're around. And if you can just help out a tiny bit, they're always happy. And it was a great experience for me to be part of this open source community. Of course, there are some rough edges. It's a new project. It's a maturing project. And the things like monitoring, observability, and so on, these are things that come later when the project itself is getting a bit more mature and it's used more in production. And if you feel like contributing to the project, you can find the GitHub repository on GitHub here on this address. And if you have some questions, feel free to ask. The QR code is actually leading to my repository, where you can find the slides and also the source code that I was showing to you. But in case if you have some questions, feel free to ask. I'm glad to answer, try to answer at least. Thank you very much for the attention. It's really cool that you were here. Thank you.